Welcome to the Meki Study Circle channel. In this video, we shall see how to do the computer drafting of orthographic projection of lines using the Solid Edge software. Looking at the problem statement, a line AB 75 mm long makes 45-degree inclination with VP, while its front view makes 55 degrees. End A is 10 mm above HP and 15 mm in front of VP. Assuming the line to be in the first quadrant, draw its projections, and find its inclinations with HP and the apparent length in the front and the top views. So looking at the problem statement, we can arrive at a set of conclusions. That is, the given length of the line is true length. It is 75 mm. And also it makes an angle of 45 degrees with VP. So this is also the true inclination. But however, instead of the true inclination with respect to the HP, we have got the inclination that the apparent length of the line that makes with the VP, which is 55 degrees. The end A is 10 mm above HP and 15 mm in front of VP. So we have also got the details of one of the extremities of the point A, which is again one of the end point of the line AB. So keeping all this in mind, let us see how to arrive at the solution for this particular problem statement. So first we'll begin by drawing the XY line having a thickness of 0.18 mm. So we will draw the XY line of any arbitrary length with an angle of either 0 or 180 degrees. So now we'll annotate the line drawn as X, Y, and also the planes, that is VP and HP. So now since the endpoint A position is given to us, so we need to mark the front and the top views of the endpoint A. So the end A is 10 mm above HP and 15 mm in front of VP. So keeping the projector line of thickness 1.13 mm, so we will mark the front and the top views of the endpoint A. So it is 10 mm above HP. So here I get the front view of the point A, and next I'll be drawing the top view of the point A, which is 15 mm in front of VP. So using the smart dimension, I can show the dimensions of the endpoint A. So this marks the front view of the endpoint A, and this marks the top view of the endpoint A. So now let me draw the locus of the endpoint A in both the vertical as well as the horizontal planes. So I'll be drawing the locus line as a line parallel to the XY line in both VP and HP. I will annotate this line as locus of A, and this is also the locus of A. This is the locus of the point A in the HP, and this is the locus of the point A dash in the VP. So now we are done with the first part. So next, looking at the problem statement, I can say that the true length of the line is 75 mm, but however its inclination with respect to the VP is given, and that is 45 degrees. So I'll go for the line, ensure it is having a thickness of 0.13 and it is a continuous line, and since the true length of the line is 75, enter the length as 75, and then the angle is minus 45 degrees. It should be a continuous line, so just change it. So this is the true length of the line. Let me annotate this as B2, which is the top view of the line, and I'll be drawing the locus line So this is the locus of B in the horizontal plane. So we can mark the angle also. So it is 45 degrees with respect to the VP. So I get the top view of the line as AB2, which is inclined at an angle of 45 degrees with respect to the vertical plane. He also tells me that its front view makes an angle of 55 degrees. So before that, let us draw the front view of this line. So for that, we'll follow the procedure. So we'll ensure it is a continuous line. So from the point B2, I will rotate this line until it becomes parallel to the XY line. So I'll be drawing a perpendicular from B2 to intersect it at the locus of A in the vertical plane. So this point is B2 prime or B2 dash. So A dash B2 dash marks the front view of this line AB2. So I can just go to the trim option and trim this part, and I can show this as the front view of the line, which is again a continuous line. So let me select the arc by center point, and then the front view is the front view of the line is making an angle of 55 degrees. So let me select the arc by the center point. This is the first point, and this is the second point. So this is the radii of the arc, and then from here I have to draw the arc at an angle of 55 degrees. So the angle of this arc that I'm going to draw will be 55 degrees. Next, I'll be drawing the front view of this line. So the thickness will be 0.50. So from this end point, so this is the distance. So this angle is 55 degrees. So you can just see that the angle is 55 degrees, which is the value of alpha. So I do know that the locus of the B will be along with this endpoint B prime. So I'll annotate this as B dash and then draw the locus of B passing through the endpoint B dash. So this line is locus of B in the vertical plane. So after having completed this procedure, I need to draw a line of 75 mm from this endpoint A dash. So I'll be taking a line of 75 mm and try to intersect that line with the locus of B to get the front view of the line AB when it is inclined at an angle. So that angle we need to find out. So I'll annotate the end point of this line as B1 dash. So I'll take the line option again. So I will be drawing the top view of this line. So the procedure is I'll be rotating this line until it is becoming parallel and intersecting with the locus of A in the HP. I can go to the trim option, trim this part, take the line option again. So join this and annotate this particular point as B1. So AB1 indicates the top view of the line A dash B1 dash. Now I'll draw the arc by using the arc by center point. So first point and the second point is the end point of this, and try to intersect the locus of B in the horizontal plane. So here I will be getting the top view of the line AB. So from the endpoint A, intersect the point of intersection of this locus of B along with the arc. So you get this point of intersection, and this marks the top view of the line AB. So we can just measure the apparent length. So this is the apparent length of the line in the front view, and this is the apparent length of the line in the top view. So this is the apparent inclination. So now let us measure what is the true inclination. So the first point is here and the second point is here. So 35 degrees is the true inclination. And next, the true inclination with respect to the VP is 45. So now we'll measure what is the apparent inclination. So the apparent inclination is 60 degrees. So the value of alpha is 55 and beta is 60, theta is 35 and phi is 45 degrees. So the value of phi and alpha was given in the question. So we have determined the values of theta and beta. So this is the procedure. So now we will insert the leader option to indicate the direction of the projections by selecting the leader option and changing the color to black. So this is the first point. Second point, and then the rotation is in the anti-clockwise direction. So this indicates the direction of the projector lines, and then we can just verify if the views are correct. So let me select a projector line of thickness 0.13 mm and try to drop the perpendicular from B dash. So it is exactly coinciding with the top view, that is B. So you can just see that the front view of the endpoint B and the top view of the endpoint B are along the same perpendicular line, which indicates that the problem is done correctly. So this is AB, which is indicating the apparent length of the line in the top view, and A dash B dash is the apparent length of the line in the front view. With this, we complete the problem.